In this video, we'll discuss another Python tool for controlling the format of our print statements, called fstrings. In our programs, we'll often need to print outputs as a combination of both text labels and data values. Now, one approach we've seen for doing this is to use the plus sign to concatenate strings together. But if we had any non-string type data, then we first had to use the str function in order to cast those values as strings before we could concatenate everything all together. Consider the following example. So here we have a name and an age variable, and then we want to print out all of that information with some labels. My name is name, and I am age years old. Now, in order to do that, we had to take concatenation symbols, so plus signs here, and join all the strings together. And since age was a number, an integer here, we had to first cast it to a string before we could concatenate it. Now, writing code like this can be a source of errors as it quickly becomes cluttered and convoluted. But fortunately, Python provides a more elegant solution known as fstrings. So fstring is short for formatted string. In Python, it's a way to embed values and expressions directly within your text strings. So here's an example. So using fstrings, we would say print still, the letter F, my name is name, and I am age years old. Notice how much clearer this is. And if we run it, we get the same output from both lines. So the syntax for creating an fstring is just to create a regular string and put the letter F in front of it. Technically, that's it. It can be single or double quotes just like a normal string. The difference is, once we have that F, once it's an F string, we can use squiggly brackets, also known as braces, within that string in order to contain values, variables, or other expressions. The result is kind of like a string literal, but with expressions evaluated directly in place. This is a process called interpolation, which means to mix two kinds of different things together into one thing. With fstrings, we can interpolate not just single values and variables, but whole expressions as well. So for example, I could say the length of something is 7 and the width of it is 5. And then using an fstring, we can put an expression inside. So I can say print letter F, and then I have my quotes. And inside those quotes, we put whatever we want to print out. So in this case, a rectangle's area is squiggly length times width squared units. Save and run our code. And it says a rectangle's area is 35 squared units. So 7 times 5 is 35. And notice again, we didn't have to do any conversion. So interpolating a string or an integer or some calculation or even a function call, it all works the same way. The expression gets automatically interpolated, converted, and concatenated together. And what we see is the values printed together in the output. Okay, so far fstrings are pretty straightforward. We just put the letter F at the front of a string, and then we can interpolate text and expressions together with a pretty easy syntax. But fstrings have even more features, though, which allow us to take very fine control of how the output is actually formatted, hence the name formatted strings. Now, there are a handful of different formatting options with a great many possible combinations, but in the general case, we add formatting to our interpolated values with the following syntax. Again, we use the letter F to denote that we're creating an fstring. We have some text and then curly braces to interpolate an expression, so expr here is whatever expression we want that to be. And now, in order to format that expression, we put a colon, and then some formatting specifier. Now, the formatting specifier has many options. So, for example, we could have some variable as our expression, colon, and then we could say underscore hat 12.4f. Now, this corresponds to 5 different formatting options all grouped together. They can be used together or independently, but they're all thrown together here. So let's go through each of them in turn, starting from the middle here. So the number 12 here is called the width specifier. This describes how many spaces in the string this value or this expression is supposed to take up, at minimum. So if your expression is the number 1002, so 4 digits long, then a width of 12, it'll be printed with 8 extra spaces. Next up, the underscore character here is known as the padding character, and this fills the extra blank spaces around our value with whatever symbol we put here. If no padding character is used, Python defaults to spaces, but we can put underscores or leading zeros or the letter Q if we wanted to. Any character you put here is going to be what goes into those extra spaces. And we'll see an example in just a moment, but let's see the rest of these specifiers. So the next specifier is this hat character here. This is called the alignment specifier. So if our width is wider than the number of digits or letters in our value, so if there's going to be extra spaces, then this is an arrow which says whether our expression should be left, right, or center aligned. Here, hat means center alignment, where right and left are the greater than, less than symbols, respectively. By default, numbers are justified to the right and text is to the left. To the right of the width specifier is a 0.4, which represents the precision specifier. The precision controls how much of our value is going to be displayed. So if the thing we want to output is wider than the amount of space we have to output it, that's to say if our value has more characters than our width specifier, then it's just going to take up more characters. If I say a width of 3, but I have to print out 10 characters, it's going to print out 10 characters. The precision specifier lets us limit the size or the upper bound on the size of our value. With strings and integers, this means it will limit the number of characters or digits that get output. But with floating point numbers, this means how many digits get output after the decimal. So I could say a 0.4 here means outputting 4 decimal places. And lastly is the type specifier, F here. And this indicates that we want the number to be formatted as a floating point number. Now we won't need the type specifier much in this course. It can be other types if needed, though F-strings do a pretty good job of not needing to care what type is actually being interpolated. As we saw before, we can interpolate strings and numbers pretty much the same way. But when we're formatting them, the reason we need to use the floating point type specifier sometimes is because it changes the meaning of the precision specifier, as I just mentioned. So with strings and integers, the precision specifier controls how many total characters or digits get displayed. But oftentimes, we just need to limit the number of digits after a decimal place. And this is how we can accomplish that. By saying 0.4f, we're saying 4 decimal places. It can be as many numbers before the decimal as it needs to, but it's only going to have 4 digits after the point. Okay, that's probably a lot of information, so let's see some examples. So let's start off by creating some values. I'll say name equals Bob now, and pi equals 355 over 113. So we have an estimate of pi there. And now let's print it out. So we'll say print f. My name is squiggly brackets name, and I like squiggly brackets pi. Exclamation, close our string, and let's try this out. So save and run our code. And we get, as our last line there, my name is Bob, and I like 3.14159, and then it's not an exact estimate of pi, so we get a bunch of numbers that aren't normally in pi. Okay. So let's try out some formatting specifiers now. So if we put a width specifier, we could say a width specifier of 8. Save and run our code again. And now notice it says, my name is Bob, and then there's 5 more spaces afterwards, and I like pi. So the only thing we changed was the width specifier on the name expression here, so that's the only thing that changed in our output, is now that our name has more space. Notice now the name field takes up 8 spaces in the output, even though the name itself is only 3 characters long. We can change the alignment by specifying, for example, to the right, with an arrow pointing to the right. And if we save and run our code, the exact same thing happens, but notice now it's right aligned and all the spaces are on the left. We can also make this center aligned, as we've seen, by putting the hat character in there. Now notice it's in the middle, surrounded by spaces. We can fill those spaces by using a padding character. This can be any character, so for example, we can put a tilde here. If we save and run our code, notice how the name is in the middle, surrounded evenly by tilde symbols. Sometimes it's useful to specify a maximum size for our value, so it's precision. So for example, if we specify a precision of 0.2, I can say 8.2 here. Then instead of printing Bob, we get Bo. Notice though that it still takes up 8 total spaces, but only 2 of those spaces are being used by the value of our name variable. Now precision is more commonly useful when we're working with floating point numbers. So we can, for example, limit the decimal places of our pi estimate here down to 4 decimal places by saying, I like pi, specify 0.4f. And now notice we only get 4 decimal places. 5 total digits, but only 4 decimal places. Notice also that it did a bit of rounding, so it turned that 159 into a 16. So the precision specifier limits the number of decimal places when it's used in conjunction with the type specifier f. If you forget the type specifier, which I can show you here, just delete this and try again. Notice now it has 4 total digits, 3.142. So 3, 1, 4, and 2. So counting all of the digits, but for some reason not the decimal point. Okay, let's put that back to an F. Save, clean our code again. Okay. Now, using what we've learned about formatting strings, let's create a small program to solve the following challenge. So it says, create a program that outputs the following table as shown in the same format. So we have a table that has 2 columns, 3 names, and 3 ages. Before we begin a solution, we should consider our design, and before I do that on this video, I encourage you to pause the video and try for yourself. And welcome back. So to solve this challenge, we need to write some formatted print statements. We have a table with a header row, 2 columns, and then 3 rows of data. So the key to making it look cleanly formatted is to use consistent sizes when we're outputting that data. So starting with the header row, we can print the 2 words, name and age. But how many spaces should we use for each of those words? How are the words aligned? What padding characters do they have? So the word name is 4 characters wide, and we can see 4 dashes on both sides of it, so 12 characters wide total. The word is center aligned, and we have dashes as padding. The age column is similar, but with 7 characters, so age is 3, and we have 2 on either side, gives us a total of 7 character width there. Then, to keep the data rows in neat columns, we just need to print those lines with the same widths each time. So let's make a new file to try and write this solution out. Over here, new file, and I will say fstring table.py. So this program is going to print a formatted table of values. So this program prints a formatted table of values according to the lecture challenge. So there's no special steps in this program. Our input will be hard-coded values in the code, and the process will be to format them properly so that we can output them by displaying it to the screen. So starting with a print statement for the header line, we have 12 spaces for the name and 7 for the age. And then we have bars to mark the different columns. So we're going to say print, we're going to make an f string, and in that f string we're going to have pipe, some value, another pipe, another value, another pipe. So that gives us our 2 columns, and then in those columns we need to put the word name, the word age, with the padding and alignment characters as needed. Now, to interpolate a string in a string, we shouldn't use double quotes in a double quote string, but thankfully we have 2 different kinds of quotes, so we can just use single quote strings here. We'll say single quote name and single quote age. And if already this looks like a lot of random characters and you're not sure you typed them right, save your work and see what comes out. So Python fstring table.py, and we get some silly outputs because I made a silly typo. So I put the F inside the quote instead of outside the quote. So it got the letter F, and then everything else literally exactly as I typed it. So let's fix that here. Let's take F and put it here and try again. This is why it's a good idea to code a little bit at a time and test often. Makes you find those mistakes before they become too big. Okay, so now we have name and age in 2 separate columns. They don't have the right formatting, so let's next make sure they have the right space. So we said it was going to be 12 characters wide here, 7 characters wide here. If we save and run again, now we have name and age with the appropriate spaces. We said they were going to be center aligned with dashes. We'll put dash hat, and the same thing here, dash hat. Save, run our code again, and that appears to work. We get a header row that looks as we expect it to. So next, we can start putting in the data rows. So the first row of data was Alice at age 20. So we'll say name equals Alice and age equals 20. Now we want to print these out, but we want to print them out in the same format. So we're going to say print again with an f string, and in that f string we're going to have pipe, squiggly, pipe, squiggly. Right, so we have 2 columns, each with a value inside of it. And now the values in there are going to be name and age, the variables that we just created. And to make them stay in strict columns, we'll make sure they have the same width in each value. So we'll say for the name, it's always a width of 12, and for the age, it's always a width of 7. Save and run our code. And now we get name and age, Alice and 20. So we get 2 columns of text printed nice and cleanly. However, the alignment for the data row that we've added doesn't match the alignments in our target output. Text by default is left aligned and numbers are right aligned, but in our target, let's come back to our target here, we can see that the opposite was true. So we need to specify the alignments for each of these types are reversed. So for name, we want that to be right aligned, and for age, we want that to be left aligned. Save and try again. And now it looks a little better. Okay, so let's add the rest of the rows. So we'll say next was The next row was Bob at age 8, and then Charles Dean at age 104. So we'll just say name equals Bob, age equals 8. And then we can actually just take this print line and put it here. Now, in an upcoming chapter, we'll see how to take advantage of repetition like this in our problems in order to automate simpler solutions, but for now, we'll just write it out a second time. If we use the same line twice, we should get the same output, but we've changed the values of the variables, so the output will be slightly different. So we get our header row, Alice and Bob. And we can do the same for the last person there, so that was name equals Charles Dean, and age was 104. And if we copy and paste, print that line out, now we have a third person there as well. So we can compare this to our target output. So we have name is centered, all the names are to the right, we have age header is centered, and then all of the ages are to the left. One thing we missed is that there's a space. So these ages aren't right up against the column. There's a space there. We can see they start in the second column. So we need to add that space into our output. Now, a simple way to do that is just to put a space directly into the output. And if we save and run our code, we can see what that does. So now we have the spaces, which is good, but now our age values are taking up one too many spaces. So our table looks a little bit broken. So a simple way to fix that is, since we're including a literal space, then the remaining value should be one fewer width in order to take up the same total width. So let's make all of these 6s, save, run our code, and now it looks like our target output. All right, and that's it for our intro to Python f-strings, a convenient and powerful way to create string literals with all sorts of interpolated and well-formatted expressions. Now that's it for this video. Don't forget to blink, and now on to the next one.